Okay. So here's the first one. Let's just zip through these. So the first one here, this is one, this was meant to be a really easy question, okay? Is when I wrote these things, I thought, okay, this real simple geometry, not a big deal. The main thing here is that I want you to use function notation. And these are all going to be, you know, they're typically either perimeter or circumference or area, things like that, right? This is an area one. So we've got a rectangle. Now, what I find happening a lot here is people are just rushing to conclusions, and it'll ask for an area and they calculate a perimeter, or vice versa. Slow down. Read the question twice if necessary. Draw a picture. I think when you draw a picture, it forces you to slow your mind down enough that you're not going to just charge down the wrong path. You know, you'll think about it enough where you kind of form a strategy, and that's really important to do as you get higher in math classes. So here's our rectangle. The width, doesn't matter which dimension goes where. Let's just call that the width and this the length, I guess. Doesn't make any difference. So if that's my rectangle, how do we calculate area of a rectangle? Length times width. Good. So we know that area equals length times width. How would I write that? 25x or x25? 25x. We always want to put the number first and then the variables, right? Okay, what part makes this a function notation, though? What do I need to do? Okay, I need to write it as a of x. That's function notation, right? So that's what it should look like. While we're at it, let's pretend it said perimeter. What would I do if I wanted to calculate the perimeter?
25 plus, oh.
How do we calculate perimeter of a rectangle?
Oh, yeah, x squared plus 50. No.
Not x squared. 2x, there you go, good. We're going to add up, we're going to get 2 times the width plus 2 times the length, right? So we would just get 2x's plus 2 times 25 is 50. And once again, what do I do to make it function notation? Of x. There it is. Okay, that's it. Slow down on those. Everybody ought to be a freebie for you next time you take this test. Slow down and take advantage of that one. It's supposed to be easy. Okay, now most of the rest of them are really just dealing with looking at these graphs and finding domains and ranges and intervals and things. And this is the part where I think people need to really slow down here and really, you know, read the question and analyze what's being asked each time. Because I would say when I looked through these tests and I looked through them in detail, I would say that probably at least half of the mistakes are not mistakes of understanding. They're mistakes of just answering the wrong question correctly, you know, providing the right answer for the wrong question. So what are they asking for here? Let's notate this. Let's underline the important parts of this question that we got to really pay attention to.
Domain.
Domain, that's huge, right? Write the domain, not the range. About half the time people wrote the range, right? It's the domain we're looking for. What's the domain? X's, right? The input values, not the output values. It's the set of all the input values for this function, all the X's that an ant could walk on. So talk to me about that then. What are the Y values are restricted, but are the X values restricted? There's no endpoints on this function, are there, right? There's nothing to tell us here that if an ant walks to the left forever, you know, it's not going to continue like it is, right? So we assume that. What about to the right? There is no vertical asymptote here that's a wall that the function runs up against. So what's that mean? It goes to the right forever. Yeah, it's going, you know, it's getting steeper and steeper, but we're talking about infinities here. Infinity isn't just a big number, it's forever, right? So if the ant continues along this function forever, there's nothing to stop him from continuing to move to the right. Everybody agree? Okay. So then what's my answer going to be for this? Okay, so negative, keep going, negative infinity. I'm writing an inequality too. There's the other thing. Make sure you
mess up on that.
Right, and that's real common. So you got to know what's being asked and what's the form of the answer going to be, right? Are they expecting an inequality or an interval? Okay. So as an inequality, we really always want to start in the middle. What's the variable we're dealing with? X, and what does X have to do? Has to be
bigger or smaller?
well, okay, it has to be greater than,
Oh,
right? It has to be greater than negative infinity and less than positive infinity. Now, I admit, this is kind of a weird thing to write, but this is the one special case that there's no limit, that the answer is all real numbers, right? We could take any x value as can be represented at some point on this graph, right? So that's our way of saying no restrictions, all possible x values, all real numbers. And that's a little different than all the other kinds of problems that we deal with, but just know that that's how we write unrestricted x values as an inequality. What would that look like as an interval?
Negative infinity. Okay.
And what kind of enclosures?
parentheses.
Has to be parentheses with infinities. You could never have a bracket with an infinity because that would imply you could get there. But you can never get to infinity. It's not a number, right? Does that make sense?
Yeah, what if it's going the other way?
Same thing. It still would be, there's still no limit, right? If it were going the other way, then that would mean the ant would walk to the right along an increasingly flat curve. But if he backed up to the left, he's going up, but always to the left. So once again, it would still be unrestricted if you're looking for a domain, okay? All right, how about this guy? What's the range of this guy? Now, first of all, what are the words I'm going to underline up here?
Range. Right there.
Range is the first one. That's a big one, right? Write the range. So x or y values? Y values. Right away, we know we're doing y values. And then how are we going to write it? Inequality. Okay, write it as an inequality. So we know we're going to be saying we're going to have a y, and we're going to write some inequalities. Now let's kind of review how we think about this. The range is the set of all the possible y values, outputs of the function. So in ant terms, all the y values that an ant could ever step on. As he walks from negative infinity up to positive infinity, what's the range of all the y values he could step on? Is there a lower limit? Is there a bottom value?
Yeah, negative 10.
Negative 10, and he can step on negative 10, right?
It'll be an open circle.
So no,
Or it'll be a
so it can be closed circle, right? Because we're including negative 10, and remember, inclusive means more ink. Including always means more ink. I got to fill in the dot, I got to make a square bracket, and I got to include an equal sign in my inequalities. All three require more ink for me writing on the board, right? So down here, he can actually step on that point, which means if we're going to go ahead and graph the range, on the y-axis, which I think is a good idea, then I'm going to have a closed endpoint right there. That's my bottom value. Is there a top value? 6. There is. And there's going to be an infinite number of these waves, but any one of these peaks any one of them is going to give me the same maximum value, which is 6, right? And then, of course, everything in between. The ant could walk on any y value in between those boundaries, right? So does that make sense that that's a graph of the range then? Okay? All right, so how do I say that as an inequality then?
Negative 10 is less than or equal to, right? Y.
Okay. So why, you're saying the right thing, but the way we want to say it in math is we always want to start with a variable. So y is greater than or equal to negative 10, so it's above negative 10, and
Less than or equal to 6.
less than or equal to 6. Would it be okay to turn that around? No, it's not. Right? We always want to write these relationships where we're going from smaller to greater values, just like a number line. Okay? I want you to notice something else here, and this is a real important connection to make, and I think everybody's really ready to make this connection now. How many endpoints are there to this interval? To the range? 2. There's a top limit and a bottom limit, right? How many inequalities are there? 2. That's always going to be the case. The number of endpoints determines the number of inequalities. I need one inequality to define the bottom limit, right? I need another one to define the top limit. Okay? Does that make sense? Okay? Domain. Well, you tell me, what am I doing?
Find the y, or the x.
X values. So I'm doing write the domain, so that's x, using interval notation, not inequalities this time, right? Okay, so what about the domain, the x values? Where that's horizontal stuff. Is there a bottom or a left limit to where the ant can be?
Yep.
What's the bottom x value?
-2.
Negative
Oh,
7.99.
-8.
Oh, okay, so it's -8, but is it included?
Right.
So what's that mean about that endpoint of our domain?
Only it's like x is greater than
Okay, so how would I write that as an endpoint then?
parentheses.
Oh, parentheses? Okay, good. And if I'm writing an actual, like I could write it as an open circle too? Same thing? Does that make sense? So I've got an open circle. If I'm just graphing the x values now, right, I'm smashing this function onto the x-axis. So I get an open endpoint at -8 because the ant cannot step on that x value. That's the boundary. That's like me walking to the door, right? If I always cut my distance in half, I never get to the door, but I'm always approaching the door, right? On the other side,
-2.
and that is solid or open.
Closed.
Good.
Bracket.
Okay, good. And so then we could just look at this and say, okay, open circle means parentheses, closed circle means bracket, and what are my endpoints?
-8, -2.
Boom, that's it. Okay,
Yeah, dude, I just needed that.
okay. Range. What kind of values?
Why?
Y values. Okay. How are we writing it?
Inequality.
Inequality. Okay, so now we're going to smash this onto which axis?
Y.
Y. Good. So is there a highest or a lowest Y value?
Highest is 2.
Highest is 2, and it can be 2, right? So open or closed?
Closed.
Closed.
Oh, and then infinity.
And then it's just going to go down forever, right? How many, okay, so how many endpoints are there on the interval?
1.
So how many inequalities do we
One.
need? 1, right? So we'll start with the variable, and what are we going to say about it? What's my one inequality that I need here to go with that
Less
endpoint?
than or equal to.
Less than or equal to, bingo, right? Because we're going below that. So y is less than or equal to 2. Okay, good? Okay, what am I looking for?
Range.
Range. So
Y.
y values, how am I writing it?
As an inequality.
Inequality. Okay? Now, stare at this one for a second. Let's be careful with this one. So they're telling us the red line is an asymptote. So what does that mean?
You always approach it, but you never get there.
Good. You always approach it, but you never get there. Okay, so if I smash this onto the y-axis, what can you tell me about the range then? Is there an upper or lower limit? There's a lower limit. Where? 4. Do I include it?
No.
No. So I'm going to get an open circle at 4, and then I'm going up to infinity. Good. So those are all the y values that the ant could step on, right, as he walks along the function. So as an inequality, how would I say that? There's only one endpoint, so I only need one inequality. What is it? Greater than. No problem, right? Okay. Range. X or Y?
Y.
Okay. Are we writing it?
Interval.
Interval, okay? So if I smash this onto the y-axis then, is there an upper limit to the y values?
Yeah.
1. And that's open or closed?
Close.
Closed, because he can step on 1, okay? What about a lower limit?
-9 closed.
-9, good. How come it's closed?
Because you can be on it on one side, you can be on it.
Okay, as long as you can be on a y value of 9 somewhere, it has to be included. So it doesn't really matter that the ant can't step on -9 here, because he can there, right? So that means it's going to be closed there, everything in between. So as an interval, what's that look like?
Y is greater than or equal to, right?
Right, so what kind of, so I'm doing interval notation, so how am I going to write that?
-9,
Brackets.
Brackets,
-9,
-9,
greater than or equal to. Oh, what?
1.
comma, 1,
Bracket.
bracket, right?
Oh, interval. Oh, yeah.
Yes, because it's interval notation. Okay, questions on that? What if, how would it change it, just real quick, how would it change it if that were open?
No bracket on the.
Ah, okay, good. That would have changed this to an open circle, which would have meant that we would have wanted parentheses on the left instead of a bracket. Right? Okay? Good. Okay, what are we finding?
Range X.
Range.
Y.
Y. How are we doing it?
Interval.
Interval. Okay. So what about this one? Is there a top value?
-8.
-8. Can he stand on that?
No.
Yes.
He can't he? Right? And I know what's confusing about this. What's confusing about this is that the endpoints are open circles. But does that matter?
No.
It doesn't matter for range, does it? Because those endpoints are not the top or bottom values. So who cares, right? The top value is right there. And he can stand on a value of -8. The lower limit is -10, and he can stand on that, right? So what's that look like as an interval then?
Yeah. Open parentheses.
Brackets. I need brackets, right? Right? You see why?
Uh-huh.
Because
Oh, yeah,
we're dealing with range, not domain,
Yeah.
right? So let's do both of them on here, just so we can draw a distinction between the two. So range is going to be closed brackets from where to where?
Negative 10 to
-10 to -8, lesser to greater, right? We're going from bottom to top for range. While we're at it, let's go ahead and do domain. What would the domain be now?
-1.
Okay, comma,
And then 10, but you just use
Oh,
parentheses because
parentheses.
you can't stand on it.
good, okay. Okay, for the domain, but not the range,
Not the range.
okay? Okay, how about this guy? What are we finding? I think, did we already do this one?
No, we did the other way.
Oh, okay.
I don't know if there's difference, but
Nah, I don't think there is. I think didn't we, let me go back. I think we did, yeah, we essentially did that one.
Yeah.
We wrote it as an inequality, but,
Let's do it again for fun.
okay, let's do it again. Why not? So what's gonna be, so we're looking at range, so y values, writing it as an interval. So what do we say? If we smush this onto the y-axis, is there a lower,
-4.
open or close?
Open.
Open,
Open.
right? Because because that's an asymptote, it can't ever get to it, right? So then what's that gonna look like?
Parentheses, -4.
Infinity.
Comma, good. Infinity with,
Parentheses.
has to be parentheses,
Because
very
you
good,
can't stop.
very good.
Big number.
Very good. Okay, range. I'm giving you lots of these, but you're gonna be ready for this test.
Oh, yeah.
-7
-7,
is less
okay, and then,
than.
This is range.
good,
so it's
range, so y values, and then +9, I'm gonna include both of those, right?
Yep.
Okay, didn't we do one like this too?
Mhm.
Writing as an inequality?
Yeah,
We did this one already,
Yeah.
yeah. Okay, here we go. Now this is what I wanted to get to. So the positive valued, negative valued stuff, right? So what about this? This was, a lot of people missed this. Okay? So let's read this carefully and let's underline all the important stuff and interpret that. And you could do this on your scratch paper, right? So what's the first thing we got to see here?
Positive value.
Okay, positive valued. Now what does positive valued mean?
Above
the
the-
x-axis.
Above x-axis. Okay, so one way we can interpret that, that means above x-axis, right? So right away, when you read this thing, you got to make that connection because it's easy to confuse positive valued and increasing. And that happened a lot, right? Positive valued means where is the function above the x-axis? What's our answer going to look like?
It's gonna have a comma. It's an inequality with a comma. and-
Okay, inequalities, good. And in this case, they want commas, but this is an old question. On the new one, for
Yeah.
sure, when you get this on the retake, it's gonna be using the or symbol, okay? So how are we gonna do this then? Let's go ahead and just find those intervals. So are we looking for x values or y values here?
X.
X values. We wanna know where are the x values that cause y to be positive, right? That cause the function to be above the x-axis. So for what x values is the ant above the x-axis? So where is that happening?
-8.
Okay, so -8 is significant. That's going to be a boundary, isn't it? What about -8? If I'm going to squeeze I'm going to write just the domain where it's above the x-axis on the x-axis. What would I do at -8?
Close circles?
Closed or open? Good question.
Open. 'Cause it's
Open.
less than.
Okay, it's open because for the same reason, let me ask you this. So is the function positive valued there? No.
No.
Is 0 a positive number?
No.
No. Is it a negative number? No. It's the boundary between the two, right? And on the x-axis is where the y value is 0, not positive, right? So we're going to have an open circle there because that's going to be an endpoint of my interval. Okay, that's where it starts is the ant's walking in the positive x direction from left to right. That's where he starts to be positive valued. He ends at -1, right? So then there's one interval where the ant is above the x-axis. So let's write that one. Is it with an inequality? What variable are we using?
X.
X. What about x?
Greater than -8.
And,
Less than -1.
okay, how many endpoints are there on the interval? 2. So how many inequalities did I use? 2. Okay. Or,
6.
what about over here?
X
X
is
greater than 6.
Greater than 6. Because everything to the right of 6, those are x values where we're above the x-axis. Agreed?
Yep.
Okay. So or x is greater than 6. So that's what it would look like in Moodle, right? Using the or symbol instead of a comma. Okay, and we're just assuming, even though this question says comma, we're just assuming that when you see this one on the test, it'll look like this. Okay? How about this? What are we looking for?
Increasing.
Increasing, where the function is increasing. Now, what does that mean? Okay, think of it in terms of maybe an ant. What's that mean the ant is doing?
walking uphill.
Walking uphill. As he walks in the positive x direction, he's walking uphill. Okay, so we'll summarize that as the ant moves to the right, he's walking uphill, right? So we got to get a picture in our mind of what are we looking for. Before you jump into this, the function is increasing where the ant is walking uphill from left to right. Okay, so where is that happening then on this function? Where does that start happening?
-4.
Okay, is he walking uphill at -4?
No.
No, he's not, because that's the minimum, right? At the minimum, that's the transition between walking downhill and walking uphill. In the same way that that y equals 0 is the transition from negative to positive values. You don't include the point of transition. It's the place where we're just making the change, right? Same thing here. We're making the change from decreasing to increasing there. So if we're going to graph this interval on the x-axis, what do I put there? Open or closed circle? Got to be open, doesn't it? Okay, it's open. Say it again.
-4 we had.
Oh, whoops, I got the wrong spot, didn't I? Yep. So, right here.
Yeah.
Right, there's the minimum, or the valley, same thing. And so that means that right there, we gotta have an open circle. So then where is he walking uphill?
To the right.
All the way up to the right, but then he can't get to that end point, right? Because the function's not defined there. So I would just go open or closed?
Open.
Open. Make sense? Okay, what if that circle were closed? Then the red circle would be closed, right? Make sense? So we're writing this how?
Inequality.
Inequality. Okay, so how would I say that then? X is
-4
and
less than 2.
2. Good? Once again, how many endpoints on the interval?
2.
How many inequalities? 2.
Let's do this.
Okay, we're almost there, almost there. Where is this function increasing?
From -7 to -2.
Okay, does everybody agree that this function's going to increase? If you think about an ant going for a hike here, the ant walking from left to right is going from the bottom of that valley up to the top of that peak, right? That's where he's increasing, where he's walking uphill. So I'm going to get open circle. Agree?
Wait. Why open circle? Because can he stand there?
He can. He can stand there, but is he increasing there?
Oh, no.
Right? See what I'm saying?
Yeah, it's on the bottom.
He's not walking uphill until he moves to the right of the valley, and once he gets to the peak, that's where he has stopped increasing, right?
Makes sense, yep.
Okay? Where is this function increasing?
From negative
Negative to
-1.
no, we're looking for x values, right?
Oh,
We want to know the x values where the function is increasing, where the ant's walking uphill, right? Now, this is kind of a weird one, but we have some additional information. We're told that this red line is an asymptote. Brendan, what's an asymptote mean again? We always get close to but never get there, right? So think about my motion to the door. If I cut my distance in half, do I ever get to the door?
no.
But am I always moving towards the door? Yeah, very slowly after a while, but I'm always moving, right? So by the same token, this guy's walking uphill forever. The hill gets pretty shallow after a while. It's hardly even recognizable as a hill, but it is mathematically, right? He's always inching closer to that asymptote. So what's the answer? Where is this function increasing? Everywhere, right? How do I say that? Is an inequality?
In it.
No. That's if it's nowhere increasing. So slow down, Mr. Sorry. How do I say no restrictions, all values? X is
Greater than infinity.
the negative infinity, and
Less than.
boom. Okay? Okay? And then last one. Where is this function increasing? And then we're good. Then you can jump into this and start it. So where is he walking uphill?
Negative.
-1 to -3.
Okay, so there's a maximum or a peak. So everything up to that point, he's uphill, right? So open circle and then left or right from there. Increasing means he's walking uphill. Is he walking uphill to the right of that?
No.
Because we're always talking about walking in the positive direction.
Yep.
And that can be confusing, right? Because you could say, well, yeah, if he walks this way, he's walking uphill, but we never do. We're always going to assume the ant is walking in the positive x direction.
So he has to skip that down part and go over to the other part.
Exactly. So he's going to be walking uphill then over there, right?
And
Because from
over.
left to right, he's having to hike up this hill. That's where he stops. Now from left to right, he's downhill. Where does he start again? At that minimum, right? So right there. Now he's going to start uphill again. That's it, right? I know it's kind of dorky to think about the ant, but man, we do it in calculus all the time. It works.
How did you write that?
What's that?
How did you write that?
So how do we write it? Good. Okay, so what's the answer going to look like? We want inequalities, right? So how do I write this inequality over here? How many endpoints are there on this interval? 1. So all I have to do is say x is greater than or less than or something like that.
And then a comma or an or?
No, an or. This says comma here, but in the other one it'll say or. Yeah. So how do we write this interval as an inequality?
X is less than
Less than
Negative
-3 or, and it might be, in this case it's a comma, right? But it's going to be or later. And then what about up here? X is,
greater than 1.
that's it, right? Right? One endpoint means just a simple inequality, right? That's it. Doesn't have to be any of those fancy compound inequalities. It's just, this is just a simple one, and that's a simple one. And it's an or statement. Okay, we good?
Yep.
Go, try it.
Yeah, that'd be perfect.
Okay, you got the test right now.